Hello everyone, my name is RF, and in today's session of circuit analysis course, we're going to solve a little more complex resistor problems. Welcome to my channel, and if you haven't already subscribed, please do subscribe into my channel. If you like the content, please like it and share it with your friends so that we can all grow together. So let's get started very quickly. Let's go to a little more complex circuit analysis questions, especially in resistor field. So we start with this one. For the following circuit, if a resistor is added in parallel with R1, which you see here, R1, what happens to the current delivered by the battery? To solve this problem, we need to brainstorm it a little more. If we consider this group of R1 and R2 in parallel as R prime, which R prime is R1 parallel with R2. Now the question asks, what happens if I add another resistor in parallel with R1? So I'm going to just draw it here. Let's call this new resistor R second. Now, if the equivalent current of R1 and R2 is R prime, what is the equivalent resistor when R second is added? I hope you agree that R second is parallel of R prime. Sorry, the equivalent resistor would be the parallel of R1 and the new R second that I just added. Question is, we have R prime and now we have R prime in parallel with R second. What happens to the current delivered to the battery? How can I understand the question? If you remember the Ohm's law, R equals V over I. So in order to figure out what happens to current, the first thing to figure out is what happens to the total resistance of this circuit. So I need to first figure out what happens to the equivalent resistance. What happens to this? We have R prime in parallel with R second. If you remember from the last session, when we have two resistors in parallel, the answer is R prime times R second divided by R prime plus R second. And now the main question is that, is this parallel equivalent greater than, less than, or equal with respect to R prime? This is the question that we need to find the answer. So in order to find the answer, I'm going to just write that inequality R prime R second over R prime plus R second. So we have an inequality which I don't know the answer yet. But on the right side I have R prime. So I don't know, is it greater than, less than, or equal? So as you know from mathematics, in order to solve this inequality, I can just multiply the denominator to R prime and bring them over here. And as a result, I have R prime R second on the left side and the box, which I don't know the answer yet. Let's multiply R prime with r prime plus r second? The answer would be r prime square plus r prime r second. Okay, look at here. We have the same term r prime r second at either side. Sorry, at both sides. So r prime r seconds are at both sides, but at the right side I have an extra term, r prime square. That clearly shows me that the right side is greater than the left side. So now, if we go back to the main problem, we were going to figure out which side is greater. Let me just extend the page a little bit. We were figuring out if r prime parallel with r second is greater than, equal, or less than r prime. And we just figured out the answer that r prime parallel with r second is actually less than r prime. It's a very important outcome which we're going to use a lot in future. Considering this outcome, by adding another resistor here, I just figured out that the equivalent resistor of this branch has decreased and R3 has not been touched. So I'm not concerned about this part, but this part, the equivalent resistor has decreased. Now let's go back to our Ohm formula. What was the Ohm formula? If you remember, the Ohm's law says R equals V divided by I. And if R decreases, I come to conclusion that the current increases. So as a result, the correct answer is C. The current will increase. Okay, and now let's have a look at the next question. In the circuit below consists of a battery, 5 identical resistors, and a switch, as you can see. The question is, with the switch open, so we first consider the switch open. As you can obviously see here, the switch is open. Which resistor or resistors has the least current flowing through it? How I can figure out the answer to this question depends on a couple of calculative methods, but I just go with the easy ones. I say just consider a current I coming out of the source. So this current can easily flow up to here, up to this point. But when the current I reaches to this point, let's call it A. When current I reaches the point A, it can't flow the same way. It has to peel off, let's say, I prime and I second. So the current I is now a combination of I prime and I second. And we know that I prime plus I second has to be I. And you guys know why. Because it's conservative. So the rule of conservation says that the current would not disappear or increase in an isolated system. So I prime plus I second has to be I. And now let's follow the path of this I second. So this I second is here and it reaches to this point. I have a very important question for you. Do you think I second peel off here and here? The answer is no, because the switch is open. And as you know, a circuit is a closed loop. If the switch is open, this is not a closed loop. This loop is now open. So it's like not having anything passing R3. So this I second flow completely through R3 and R4. Same current passes through R3 and R4. Now, back to question. Which one of these resistors has the least current flowing through them? R3 and R4 are in series. As you know, in series, the current flows equally through the resistors. And the equivalent of R3 and R4, as they're identical, I can call them 2 times R. So 2R is in parallel with this guy, R2. So 2R is in parallel with R2. And then the circuit will be just simplified into R1, parallel of R2 and R3, R4, and here we have R5. R5, R1, here we have R2, parallel with R3 plus R4. If I consider current I, same current that I considered here, flowing from the source, this current flows equally from R1 and goes to the equivalent of R2 with parallel of R3 and R4. So this current, I know that peels off a little bit here. That used to be R3 and R4. So if I has to be divided between R2 and the equivalent of R3 and R4, the answer to question comes down to this point. Which one of these two, R2 or the combination of R3 and R4, would get the higher share or the lower share of current? As they're all equal resistors, R2 has the value of R, and R3 plus R4 again has the value of R, which if we add them together will be 2R. So current I reaches to a point that has to decide between R and 2R. Now, if we find the solution of this part, we find the answer. I call this one I prime and this one I second. Which one is higher? If we have a very closer look, both of these, I mean both R and 2R, has the same potential. If you see, the heads are connected to the same point and the tails are also connected to the same point. What I can concur from this is that if we consider Ohm's law, R equals V over I, if this term is constant, the higher resistor leads to a lower current. So I guess the answer is easy now. Which one of these two is higher? Exactly, 2R is higher. So resistor R3 and R4, which have the same share of current as they're configured in series, has the lowest current. The answer is option C. I hope it's obvious for everyone. Now have a look at this one. If the switch in the circuit below is closed, what happens to the current passing through R3? R3 is here, this resistor. If this switch is closed, okay, let me just close it. What happens to R3? Assume all resistors are identical, and that is that it's an ideal system. Ideal system, we will talk about that later. But just assume that all resistors are equal, and I just close this switch. What happens to the current passing R3? If the current I flowing from the source reaches to this point, again, as I mentioned, it has to peel off into I prime and I second, so that I prime plus I second equals I. And now let's follow I second. I second reaches here. And we have a very, very important basic of circuit analysis. If a resistor, if the head and tail of a resistor is connected to the same point, just like what's happened here, if we follow this path, the switch is closed, so the heads and the tail of resistor R3 are connected to the same point. We call this condition a short circuit condition. And we just show it as SC. We can announce that R3 has been shorted out by a wire or by any cables. What happens to R3 if it's been shorted? There is no current, absolutely no current would pass R3. So just remember, if the head and the tail of a resistor is connected to each other, that resistor is shorted out. So the current I second will not pass R3. The whole current will pass this shorted path and it will continue passing R4. Because current doesn't like challenge on its way. If I were the current I second, I would not pass R3 because there's a better path. There's a better path with zero resistance. This path has zero resistance, so I would not pass R3. I can just easily bypass R3 and continue my path here. Okay, so the answer is D. And last but not least is this question that says another resistor is added to this system, which is called R6, but they're all identical. You can say another R is added to this system of 1, 2, 3, 4, 5 R's. Okay, what happens? Assume all. Sorry. What happens to the total resistance of the system when the switch is closed? So let's just close the switch and see what happens to total resistance of the system. So first scenario is without R6. If R6 is not existed, what would be their total resistance? And if now we add R6, what happens? You guys should be able to answer very quickly. There's a short answer to that. I can tell you, as R6 heads and tails are connected to the same head and tail of R3, I can say R6 is in parallel with R3. I hope you agree that R6 and R3 are parallel. And as we just witnessed in a couple of questions ago, when two resistors are parallel to each other, the equivalent resistor is less than each one of them. That's a very important decision that we're going to make here. If two resistors are in parallel, the equivalent resistor is less than each one of them. On the other hand, if two resistors are in series, the equivalent resistor is greater than each one of them because they just add up when they're in series. Okay, that's the short answer because R6 is in parallel with R3, so the equivalent resistor is less than each one of these resistors. So adding this R6 in parallel with R3 has decreased this part of the system. And we know, based off the Ohm's law, the voltage has not changed because the source voltage is DC and it's not changed. If the resistor is decreased, the current will increase. But this is not what the question is asking. It's just asking that what happens to the resistor. You can just easily say it decreases. And if it was asking for current, what happens to current, we would just say the total current of the system also increases. But just for the sake of resistors, the total resistor of the system will decrease. You guys can just practice. Try to solve this in another way. Try to just figure out the total resistance, like the equivalent resistance of this system without R6, and then try to figure out the equivalent resistance with R6. I just quickly want to say the answer to that. So here is what I found without R6. The answer is 2.67 R, and with R6 the answer is 2.60 R. Go ahead and try to figure it out. Thank you very much for watching the video. Please, if you liked it, share it with your friends and let's all grow together. Thank you very much. Have a wonderful day.